Hello teacher. Hello students. Welcome to today's lesson on the method of development, parallel line development of cylinders. In our last lesson, we have seen the rules and steps of parallel line development and the development of rectangular, truncated, and oblique prisms using parallel line development. Let's briefly revise the previous lesson as usual. Parallel line development is a method used to develop prisms and cylinders. Development of objects with parallel elements or parallel lateral edges begins by constructing a stretch-out line that's parallel to a right section of the object and is therefore perpendicular to the development of a right rectangular prism elements or lateral edges. In the front view, all lateral edges of the prism appear parallel to each other and are true length. The lateral edges are also true lengths in the development. The length or the stretch out of the development is equal to the true distance around a right section of the object. In our today's lesson, we will discuss the rules and steps used for the development of cylinder using parallel line development. We particularly see how to develop the pattern of a right circular cylinder, a truncated cylinder, and an oblique cylinder. The surface development of cylinder is based on the parallel line development or stretch-out line method. It's made by rolling the cylinder out on a plane surface. In the pattern for cylinders, the stretch-out line is straight and equal in length to the circumference of the cylinder. If the base of the cylinder is perpendicular to the axis, its rim will roll out to form the straight line. If the base is not perpendicular to the axis, we will have to make a right section to get the stretch-out line. Students, as we said before, in this lesson, we will see the development of a right circular cylinder, a truncated cylinder, and an oblique cylinder. We use somewhat different steps to develop the pattern of these cylinder types. We'll discuss the development of each one by one. First, we'll see the steps for making development of a right circular cylinder. In order to develop the pattern of a right circular cylinder, we should follow the following steps. Draw a plan and elevation of a cylinder with the given dimensions. Divide a circle of the plan in a number of equal parts by drawing diameters. Project these divisions in the elevation. Each line in the elevation represents a generator. Draw horizontal line on the side of the elevation. These lines are called stretch-out lines. The length of these lines is equal to the circumference of the cylinder. Divide the stretch of the line into the same number of equal parts in which the planned circle has been divided. The rectangle so obtained is the development of the lateral surface of the cylinder. Well, students, let's do an activity to check how much you've understood the lesson. The views of a circular cylinder are given on the screen. Make the development of this cylinder correctly. Don't forget to use the steps you have just learned. Welcome back. Did you complete the exercise? I'm sure you did. The solution to the activity is given on your screen. Compare your answer with it. Students, how are you doing so far? I hope you are doing great. Next, we'll discuss how to develop the pattern of a truncated cylinder. Do you know what a truncated cylinder is? Let's see. A truncated cylinder is a cylinder cut by a plane that's not parallel to the path. In order to develop the pattern of a truncated cylinder, we should follow the following steps. Draw the front and top views of the truncated cylinder. Divide the top view of the cylinder into appropriate number of equal parts. Then number the resulting surface line elements starting from 1 at the shortest surface element. Also number the elements of the front view in agreement with the numbering on the top view. Also draw the auxiliary view of the inclined surface. Draw the stretch out line and mark points A and B such that AB is equal to 2PR, which is the circumference of the cylinder. The circumference may be laid out without calculation as shown on the screen. Divide AB into the same number of equal parts and mark points 1, 2, 3, etc. Draw perpendicular lines to the stretch out line through points 1, 2, 3, etc. Transfer the true length of all line elements from the front view to the corresponding line on the development to locate points. Draw a smooth curve through points using French curves. Attach the lower base and the inclined face to gauge the development of the entire surface of the cylinder. Well, students, here is a practical activity for you. The views of a truncated cylinder are given on the screen. Make the development of this cylinder correctly. Don't forget to apply the steps you have learned. Welcome back. Did you make the development of the object correctly? Wonderful. The solution to the activity is given on the screen. Compare your answer with it. Well, students, how are you doing so far? I hope you are enjoying the lesson. Next, we will look at the development of an oblique cylinder. Do you know what an oblique cylinder is? Let's see. An oblique cylinder is one with bases parallel to each other, but not aligned to each other. As a result, the lateral surface of the cylinder appears oblique. In order to develop the pattern of an oblique cylinder, we should follow the following steps. Draw the front and top views of the oblique cylinder. Also, draw the right auxiliary section, since the cylinder may be considered as a prism having an infinite number of edges. The development of an oblique cylinder can be made in a manner similar to the oblique prism. To develop an oblique prism, a finite number of surface elements will be considered, say 12. Divide the right section view of the cylinder into 12 to get the 12 surface line elements and number them in all views as shown on the screen. Draw the stretch out line that is equal in length to the circumference of the circle, representing the right section of the cylinder. Divide the stretch out line into the same number of equal parts, locating points on the stretch out line. Draw perpendicular line to the stretch out line through points A, B, C, etc. Transfer the true length of each line element from the front view to the development, locating points. Draw smooth curves through points using French curves. Attach the base of the cylinder to complete the development of the entire surface of the oblique cylinder. Well, let's strengthen your knowledge of developing the pattern of oblique cylinders by doing some activities. The views of an oblique cylinder are given on the screen. Make the development of this cylinder correctly. Don't forget to follow the steps you have learned. Welcome back. Did you complete the exercise? Excellent. The solution to the activity is given on the screen. Compare your answer with it. Well, students, I hope you have gained a lot of concepts from today's lesson. Before we come to the end of the program, let us summarize the main points. Parallel line developments are made from common solids that are composed of parallel lateral edges or elements. Examples of this are cylinders and prisms. The cylinder is positioned such that one element lies on the development plane. The cylinder is then unrolled until it's flat on the development plane. The base and top of the cylinder are circles with a circumference equal to the length of the development. All elements of the cylinder are parallel and are perpendicular to the base and the top. When cylinders are developed, all elements are parallel and any perpendicular section appears as a stretched out line that is perpendicular to the element. Well, students, I want you to copy the exercises from your textbook and keep on practicing. Teacher, please assist your students on their needs while they are practicing after the lesson. Well, we have come to the end of the program. I hope you've enjoyed learning the lesson as much as I have enjoyed teaching it. In our next lesson, we will learn about the radial line development of cone. Until then, thank you, teacher, and thank you, students. Goodbye.